Right, we've got a question here where we are drawing or interpreting regions on a graph. So find an inequality that defines region A and another that defines region B. Let's do this. Ooh, yeah, like it. Okay, region A, not so bad. This is a horizontal line, and this line itself, if we just focus on it, is y equals 2. So region A will be everything that's less than that, and it's going to be y is less than 2. However, because this is a solid line, rather than a dotted line, it also includes 2, and therefore it's going to be y is less than or equal to 2. Really important to know that. And I suppose it's a bit like, okay, I'm just going to, when you have it with a 1D line, this includes the points and this doesn't. It's similar with a dotted line in that respect. The more ink you have, the more ink you have in your inequality. The less ink you have, the less ink you have in your inequality. That's the sort of thing I'm trying to say. All right, region B. This does not look easy because it's going to be we can't sort of just easily look at the straight line here. So what I'm going to need to do is use y equals mx plus c and draw a little triangle, and I can see that if I go along 1, I go down minus 2, and therefore it's got to be, this line has got to be y equals minus 2x, but I don't know what c is. But what I can do is I can substitute in a point. Let's use this one. Okay, so this point here, I know when x is 5, y is 8. So it must be that 8 is equal to minus 2 times 5 plus c. I'm just going to write this down. I've used x equals 5, y equals 8, and I've substituted that point in, because then I can see that this is minus 10, so I can add 10 onto both sides, and I'm going to get c is equal to 18. So this line is y equals minus 2x plus 18. I could check it if I wanted. When x is 8, I'm going to get minus 16 here, and then when I add 18, I'm going to get 2, and I can see, yep, that works. That's where they cross. Brilliant. So my final answer is going to be everything above this line, including the line. It's going to be y is greater or equal to minus 2x plus 18. Okay, believe it or not, that's the easy part of the question. Shade the region on the graph given by the inequality y is greater or equal to 6. Actually, this is not so bad. Let's get the line going. So that is y is greater or equal to 6. Well, we've already put y is less than or equal to 2, so it's going to be a similar sort of setup. It's gonna, this is y is equal 6, and then it's greater or equal to 6, so all I'm going to need to do is shade up here. Shade the region. Yep, that's enough. It doesn't ask me to label it. That's okay. A fourth shaded region, given by the inequality y is greater or equal to kx plus 2 is added to the grid. The unshaded region now has area 23. Find the value of k. Alright, how are we going to do this? Alright, so I'm going to keep my part, so this is all sort of adding together because I need to keep my part B in there. And then think about this. This is a 5-mark question. Right, first of all, let's just put some possibilities in. So we know, again, it's y equals mx plus c is a straight line. So we got kx plus 2, so I know it's going to go through here. But I don't know whether it's going to be like that. That would be a, what would that be? That I should make it go through the corners. So here, yeah, it could be that, or it could be, actually, let's just have a little look. Is that 23 or more than 23? If we just count the squares, 1, 2, 3, 4, 5, 6, about 7, 8, 9, 10, 11, 12, about 13, 14, 15, 16, 17, 18, maybe 19, 20, 21. So you know what? I think it's going to be more steep than this. And what I'm thinking is, let's use the area. If we want to be exact, let's use the area of a trapezium. So I know the base is going to be 8 along. I know the height is going to be 4, but I don't know this here, so I'm going to call this x. Now I know the area of a trapezium is given, you add these two sides together, you have it, and you times by the height. So I can do a half x plus 8 multiplied by 4, that's going to be the area of my trapezium. X plus 8, halve it, times by 4, and I can set that equal to 23, and I can solve to find x. So I can do a half times 4 is 2, divide by 2, we're going to get x plus 8 is equal to 11.5, and that's going to mean that x is equal to 3.5. You know what, I think we have to do it this way. I can't, unless you sort of do trial and error another way. So now if I move this, I know that this length is 3.5. At the moment I've got it as 3, and I saw that wasn't quite enough. So if I make it 3.5, put it exactly halfway in between, I think we've got the line. Okay. So now this length is 3.5. I can see I've got y equals kx plus 2. What's k equal to? Well, if I go along 2, I'm going up by 3. So I think the gradient is 3 divided by 2. We can check because it would give y equals 3 over 2x plus 2. And when x is equal to 2.5, I'm expecting to get y equal to 6. That's not going to quite work. I've just realised I can't be correct here. It's about 1.5, but I think I've judged it by eye, and I've not judged it quite correctly. So, okay, I've got another way of doing this. Sorry, I think I've made a mistake. Shocking. So I think I've got y equals kx plus 2, but now what I have is a point that the line goes through. So I know this is 3.5, so when x is 2.5, y is 6. X equals 2.5, y equals 6. I can substitute that in. 6 is equal to 2.5k plus 2. That means 2.5k is equal to 4 if I subtract 2 from both sides. Yeah, this is better. We can do 4 divided by 2.5. Actually, that gives us 1.6. So you see where I was coming from with that 1.5. K is equal to 1.6. But this definitely works now because it matches my equation. It's a tough question because, you know, I nearly fell for that. Because I thought surely it's going to go through that point, but it doesn't. It just is slightly above the point. So you have to be careful and do it this way, or a way similar to this. K is 1.6. That is a nice last question to the paper, I've got to say, or you might think it's horrendous, but it's a challenging one. This very last part. I hope that makes sense. Just trying to think of, is there any other way you could do it? Well, you cannot count the squares and do this by trial and error. That's not going to work. So I think you have to do it by finding the area of the trapezium in a similar way to what I did. Work out the base, sorry, the top length, and then realize that the line is going to go through that top length to make it work, and do what I did. I think that is the only way of doing this question.